I see it was started. Hello, everyone. I'm Yegor Chikunov. I'm a lead developer in Experience-based UI team. And today I'm going to be presenting and demoing what progress we did on UI extensions topic. So UI extensions is a very requested feature that required considerable amount of research and communication with our clients to understand what exactly do they want to achieve, how do they use UI extensions at the moment in the classic UI, and what behaviors are exactly important for them. So at first we've conducted quite an extensive research with our customers to understand those things. Um, Afterwards, we outline a set of requirements. So for UI extensions feature to be useful, it should support most common extension scenarios, at least at first. So we're going to start with the most common scenarios, and over time, we're going to add more and more functionality to more exotic behaviors. It should have well-defined and documented API. I would like to take a bit more time on this point. So while making an extension framework, there is a tendency to expose as much functionality of the host application as possible. And this sometimes leads to the situation where you're exposing too much functionality, too much of internals of the system, which makes it very difficult to upgrade to new versions because you don't have a clearly defined scope of API that you're exposing. As an example, it could be something like, imagine that your application has an event bus, and you are exposing it directly to extensions as is with all of the possible messages. While this is very flexible, it allows to have a very deep integration with the host application, but it also makes it very brittle because any kind of change to this event bus or to what kind of messages are there uh, leads to problems with upgrading to a new version. We wanted to avoid that. Um, Next, anything that we would come up with should be based on industry standards. We shouldn't reinvent the wheel. We should use as much as possible of the things that were already defined before us. It is very important to have a convenient developer flow. So it should be very easy to create an extension from scratch. We are trying to define a flow where you would be able to create an extension from scratch using a single command and get right into it, see how this extension works. You would be able to target any compatible host system. You won't need to like upload an extension before you can see how exactly it works. So that develop process is going to be exactly the same as you would develop any other application. It should allow usage of third-party dependencies because extensions are used, well, quite extensively across our client. We cannot limit what kind of libraries you can use, what kind of frameworks you can use, and so on. Because there are lots of possibilities that we just cannot envision. So the system should be flexible enough to allow all kinds of different third-party libraries if extension implementer needs them to use. It should be possible to customize the build process of the extension. Initially, we played around with the idea of a black box where we would provide a certain set of commands that would completely hide from the user how an extension would be built, what is actually used for it to be built, what exactly bundler we're using, and so on. The downside of this approach, it makes it very difficult to cover all of the use cases, all of the possible use cases that our customers have. So instead of trying to hide all this complexity from the user, we are providing a good starting point that can be altered afterwards to your needs. With this in mind, we still had to define some limitations. First, an important limitation is that our extensions are React-based. We do not support framework agnostic extensions. You won't be able to write them in Angular or Svelte or any other framework. And the reason for this, it simplifies integration with the system that we have. Integration that we're providing, it is heavily React-based. And at the same time, it decreases the maintenance that we need to provide, which in turn allows us to implement more features. Another thing, and I would talk about it a bit more in the further slides, versions of third-party packages shared from the host application, they're fixed. You cannot upgrade them, meaning that if you are building an extension for a certain version of sites, the version of React that is used by sites should be the same version that you're using for your extension. You cannot have an extension that uses React of a newer version. I would explain in detail in the future why is that. When we started implementing UI extensions, we isolated three main pillars of it: framework, extension points, and command line interface. So let's start with the framework. Framework defines what kind of format of extensions are we using, like technically what it is, an extension, how this extension exactly is uploaded into the host application, how exactly host application and extension would communicate with each other, how would they share data, what's going to happen with the data loading, access tokens, things like that. What kind of functionality is going to be provided for extensions on top of the data that is shared. Let's say we want to provide some reusable components so that you would be able to create extensions using our design system so that they would seamlessly integrate into the application. For extensions format, we chose already existing add-on service package format. It can contain multiple backend and front-end extensions at the same time. Each front-end extension is a standalone React library, and each front-end extension technically can contain multiple extensions. So most probably you don't need multiple front-end extensions in a single add-on. The benefit of supporting this format is that you can create an add-on that would contain both backend parts and the front-end part. So you can have a data extender on the backend that provides some data, and a column extension on the front end that would render this data in a table in a specific way. And you can update both together. For the front end part, loading of extensions, we chose to use System.js format. It provides cross-browser support for dynamically loaded JavaScript modules. It is technically, you could have achieved that using ES standard, but sadly support across different browsers is not exactly aligned at the moment. In the future, we might switch to it, but there is no telling when that's going to happen. It is natively supported by Webpack and Rollup. Those are two most popular bundlers for the front-end development. And so both Webpack and Rollup natively can output System.js libraries in System.js format. It is battle tested. It is commonly used for micro frontends at the moment. And if you look at it from some point of view, what extensions do is very similar to what micro frontends do. It is a standardized format and it is quite stable. It exists for, I think, over 10 years already. Then how exactly do we load an extension? And this is an important part, which returns us back to why you cannot have React over newer version. So the way it works, while you're developing an extension, you're referencing some version of React, some version of other libraries, like models and OpenAI client. Those are packages that we're going to provide. You're referencing some specific versions, but the build process, when it bundles your extension into a single or a number of JavaScript files, it will ignore all of these packages. The reason for that is that at runtime they are provided from the host application, because all of these libraries, they do not allow to be to have multiple instances in the same code space. You cannot have different versions of React. Well, technically you can, but it creates all kinds of troubles with communication between an extension host application. And so what happens is when we load, let's say, extension 1, we're going to provide React models and OpenAI client from the host application, share it from the same memory, while everything else is going to be bundled in the extension itself. So this way, you can use any other library. It's going to be bundled together. But for the ones that are provided, you have to use the versions that are right now in the inside in the host application. During the loading of an extension, we are validating that the versions that you have, or the versions that you referenced when you were building your extension, are in the range of versions that we support. Otherwise, there's going to be an error message about this. Now, how do we exactly organize communication between an extension and the rest of the application? We are defining something called data context. So the idea is that each context provides some data and functionality that would be available inside this context. Those contexts can be nested. They can be infinitely nested, and the deeper you go, the more data and functionality you have. So a single extension in a particular place can access all of the context that it resides in. One side effect of this is that any kind of additional functionality that we would provide via, or we would add to contexts over time, they won't change API of a specific extension point. So if you have an extension for, I don't know, Context Explorer action, then it doesn't affect you that we're going to add more and more data into the context in the future. It's still going to work as is. This is a demonstration of how contexts are nested into each other. And so in the Context Explorer table context, you're going to have access to all the data and functionality that is provided by Context Explorer context and so on. Which also allows us to define those data contexts independently from endpoints. From endpoints, I mean extension points. Because it means that we can define a bunch of contexts, and then we can say, well, in this place, we're also going to have an extension point. When we edit, it's already going to have access to everything above. So we don't need to specify for each extension point what kind of data it can access. It all depends on where it is. For the data loading from the backend specifically, host application, so sites, is going to expose a large number of query and mutation hooks to extensions. This way, the cache that is used in the host application is going to be shared across host application and all of the extensions, which means that if you loaded an item of a specific ID in an extension, it will be already cached for the host application. So when it's going to show some data that relies on this item, initially it's going to show cached data. We also have refetching mechanism on top of that, which speeds up things considerably. So you don't need to reload the same data across different extensions all the time. Another important part is that host application works. It doesn't work directly with the models that are returned from the backend. So a backend returns some DTOs, data transfer objects, bugs of data. We actually convert them into our own model structure. All of the queries and mutation hooks, they already return data in this model, so you don't need to convert anything yourself. At the same time, we do provide OpenAPI package, a separate OpenAPI package that you can use to request something from the backend directly. Maybe there is no query for it, or for some other reason. If afterwards you want to interact with the host application, you would need to convert the data that you received into models. There are utility functions that we provide to do that. As an initial iteration, we provide a limited number of components and hooks. So for now, we're going to provide 4 or 5 basic components that you can utilize, like text, button, icon, link. Text link I didn't mention here. Some utility hooks like use confirmation that would allow you to show a model, confirmation model if you need so in your actions, for instance. Use notification that allows you to show toast notifications and notifications that go into the message center. And use user profile that provides a current user profile. Queries and mutations, we provide lots of queries and mutations. I don't mention all of them here. I think it's over 100 different hooks. All of these are actual queries and mutations that are used in the host application. So all of them are tested with a defined API. Now let's talk about extension points. So extension point is a specific place in the application that allows you to, well, extend it. This is not an exhaustive list of extension points that we are providing. This is just a demonstration. So for instance, at the top bar, you can see we have custom primary navigation extension point. I didn't mention all of the possibilities there. Technically, this is not a single extension point. These are multiple different extension points. What I mean by that is that we have an extension point that allows you to configure primary navigation, like reorder of items, or remove some item, or add a new one. And we have a separate extension point that actually creates a new one. So basically, it is a 2-step process. First, you create some primary navigation item, and then you add it somewhere in this in the top bar, and you decide where. Or maybe if you don't need to add a new one, you just want to, I don't know, hide activities, you can do that also. And it is a similar pattern to multiple of our extension points. So for instance, for custom actions, you can add a new custom action, but also you can customize the toolbar itself. You can customize the order of those items, how they grouped, replace one of the actions, and so on. We also have ability to add custom columns to the table. And in tandem with the custom actions, we have customization of a context menu. You can customize context menu in the table, and you can also customize it in the tree. All of these extensions are also available in the Activities Explorer. I'm skipping field extensions. I would show more during my demo. Here's a list of extension points that we are providing initially. So we're going to have extension points for primary navigation. We're going to have an extension point that allows you to add localization, so translatable strings. We recommend that all of your strings would be localizable. We provide extension points for item editors. So those are extensions for fields and our rich text editor fields, which is a bit of its own beast because it has its own extension points, so to speak. We provide extension points for Activities Explorer with custom actions, custom action bar configuration context menu, and Context Explorer extension points that I already mentioned. Then the next part is the command line interface. With the command line interface, we wanted to simplify the development process, well, the whole development flow of for a new extension. So it allows you to create a new add-on service add-on from scratch. It provides a initial structure that you can utilize, and this structure is then a way that makes it possible for you to add backend extensions in the future. It might be a bit overcomplicated when you just have a single front-end extension, but you can adjust it to your liking. It provides an environment to develop and test extensions locally. This is an important point. So we would provide a possibility to develop your extensions targeting some environment. You would develop it on your machine. You would test it thoroughly, and then you can upload it when it's ready. It simplifies creation of a ready-to-use add-on service package. We provide a command that allows you to pack what you have into a thing that you can upload to add-on service straight away. It was designed specifically as a scaffolding tool rather than a black box. By that, we mean that it provides you some initial structure. It provides you a ready-to-use project that has ESLint, that has built-in pipeline, that has all of the configuration that is you would usually encounter in application development. But it doesn't restrict you to that. So after it generated the initial structure, you can do whatever you want with it. You can up to changing the built-in library. So out of the box, we provide Webpack. If you really want to, you can switch it to rollup and change the build completely. The only important part there is outputting system.js files and not bundling packages that are going to be provided at runtime. So first command is create one. It creates a basic front-end structure, as I said. It requires an environment URL that's going to be used as a target for development. The important part here is that this target environment should be compatible with your extension. So you're with specifically CLI that you're using. We're going to provide a table of how different package versions correspond with a certain version of sites. Yeah, and it generates a project with Webpack linked in as a development server. This development server allows to show and view this extension on this remote target environment. How exactly development server works? This part is important if you would like to customize any part of the output from the CLI. So with a standard flow, you have communication between the browser and the application server that is somewhere remotely. So you open your browser, there's a request to the application server, it responds back, and so on. In order to make it possible to develop extensions, we are starting up a local development server. So all of your browser communication goes directly to the local development server. This local development server proxies all of the requests, except for extensions, to the target application server. And specifically request to extensions actually goes to your local code that's going to be provided seamlessly, and then you would see it on this target application server. You might notice that it is very similar to man-in-the-middle attack in principle of how it works. Because of the way we approach this, during the development process, you will see notification from Chrome about HTTPS, because we have to proxy your HTTPS requests through the development server to the target application server. If you don't like this warning, you can generate your own HTTPS certificate, and then it's going to be safe. And we provide a pack command. Pack command takes as an input manifest file and the reference to the folder where all other files are placed. And then it packs them all together into a single add-on manager, add-on service package that's ready to upload. It works seamlessly with the create command of CLI. So the project that we are generating actually has all of the scripts wired up already, but technically nothing stops you from creating, from packing add-on package yourself if you want to, or packing some other project that was not generated using the CLI. So these two commands are done in a way where they can be used independently. This concludes my presentation.